Okay, so let's put all of this together, all of our knowledge, all of our wonderful knowledge about motion graphs. So the first thing we need to look at when we're looking at a motion graph is what kind of graph is it? You'll notice I have both types on here, both position versus time and velocity versus time. I'm going to do two of them. What kind of graph is it? And as soon as you know what kind of graph it is, you next need to think about what is the key to this kind of graph? What is the key to analyzing this type of graph? If it's a position time, we're looking at the slope. If it is a velocity versus time, we are looking at the, ooh, bad marker, the y value. All right, slope, y value. Maybe I can get a different marker. Pause. Got it. All right, so the first one that I want us to consider, first graph I want us to consider is a graph position versus time that looks like this. Now these are a little bit different. Position versus time graphs, we are going to have curved lines. You won't see a curved line, at least in this class, you won't see a curved line for a velocity versus time graph, but you could be for a position time. So on these graphs, I want to answer the same two questions we did before. I want to know whether the velocity is positive or negative, and I want to know whether it's increasing, decreasing, or staying constant. Okay? So on this one, position versus time, we're going to look at slope. So is the slope positive or negative? I think it's fairly easy to see here that all of these slopes are going up and to the right. They're positive. Therefore, whatever this thing is doing, it's moving in a positive direction. And now, is the speed increasing, decreasing, or staying the same? Again, I can answer that question by looking at the slope. Is the slope increasing or decreasing or staying the same? Well, I know the slope isn't staying the same. If the slope was staying the same, it would be a straight line. No matter where it is, it'd be a straight line that looks like this, or looks like this, or looks like this, something like that. None of those are happening here. So the slope is changing. So the question is the slope increasing or decreasing? Well, you can see here, hopefully you can see, if I blow this particular point up right here and make it bigger, it might look like this. And if I blow this point up right here and make it bigger, it might look like this. And if you do that, the slope is going from that to that. That slope is getting flatter. In other words, the slope, the value of the slope is decreasing. So if the slope is decreasing, the slope is getting flatter, that means the speed is also decreasing. So this object is moving in a positive direction and slowing down. So it wouldn't be a bad idea to write this, that to know that increasing speed, for the slope at least, means the slope is getting steeper. Decreasing speed means the slope is getting flatter. Flatter. It looks like flatter, but it says flatter. So if the slope gets flatter, we're slowing down. Positive direction, slowing down. The question is, how do I draw the same motion on a velocity versus time graph? So I want to draw positive decreasing speed, positive decreasing velocity on a velocity time graph. Well, how do I do positive velocity? Well, remember, these are positive y values, these are negative y values. So to do positive velocity, whatever I draw has got to be up here, so I'm not going to do anything down here. Decreasing or slowing down means that the y value will be getting closer to 0, not farther away from it. So if I'm going to draw something up here that's getting closer to 0, the line should look like this, and it is going to be a straight line. There are no curves, so no curves, no curved lines on the velocity versus time graph. This is the same motion as this, just on a velocity versus time graph. All right, I want you to do the same thing. You might need to pause the video for, let's do this graph. There's another graph, position versus time graph. Figure out whether that speed is positive or negative. Figure out whether the speed is increasing, decreasing, or staying the same. Pause the video, figure it out. All right, here we go. Video is going again. These slopes are all positive, so you should have said that is positive velocity. The slope is actually getting steeper here. It might look something like this at this point, something like that. At that point, the slope is getting steeper. Steeper slope means higher speed, so that is positive increasing speed. This object is moving in a positive direction and speeding up. How do you draw positive increasing speed on a velocity versus time graph? Pause the video and do that. All right, positive increasing speed. Positive means we're above the x-axis, nothing down here. Increasing speed. Increasing means to speed up, you're going to be going away from zero now. So positive increasing speed would look like this. Again, no curves. That line might be a little curved. It's supposed to be straight. But that's what it would look like. Same motion on a velocity versus time graph. Two more. We go ready? Next one. We'll draw this one, and we'll draw this one. Those two. Take those two. Decide whether the speed is positive or negative, or velocity is positive or negative, and decide if it is increasing, decreasing, or staying the same. Pause the video, decide that. All right, you should have decided that for both of these, all of the slopes on both of these are going down to the right, so the velocity would be negative in both cases, going backward or to the left or some negative direction. And in this one, the slopes are actually getting steeper. You can imagine if you were a person and sliding down this slide, the slide gets steeper and steeper and steeper and steeper. Steeper slope means higher slope. It's a negative slope, but the slope is getting steeper, therefore the speed is increasing. Whereas in this one, the slopes are getting flatter and flatter and flatter, which means the slope is decreasing. If the slope is decreasing, so is the speed. So once again, I want you to draw these motions, match the motion to the velocity versus time graph, see what you can get. Pause the video and do that. All right, we want to draw negative increasing velocity. Negative velocities are going to be negative y values on a velocity versus time graph, so I'm going to have nothing above. Everything negative has to be below. And if the speed is increasing, that means my speed has to be going away from zero. So the line below the x-axis that goes away from zero, not towards it, would look like this, which can be counterintuitive because people say, no, that's going down, it's slowing down. No, these y values are getting farther and farther away from zero. We're speeding up right here. And then the last one, we want to do y values that are slowing down, so we want negative decreasing speed. Once again, negative speeds are not going to be above the x-axis, they will be down below. And if the speed is decreasing, the y values have to go towards zero, so it's going to look like that. Again, a lot of people have trouble with that because it looks like it's quote-unquote going up, but it's not going up. Those y values are getting closer to zero. Therefore, this object, this car, whatever it is losing speed. It's slowing down. So we need to think about all these things and be able to put them together when we consider motion graphs.